All right, our last lesson on differentiation for now, and this is called implicit differentiation. So pause the video and try finding the derivative of each of these four things. So when we find the derivative of this, we have to recognize that it's composite and we need to use the chain rule. So the derivative of the outside, leaving the inside the same, times the derivative of the inside. Here we have a variable in the denominator. We have to use the quotient rule. And we'll have the denominator, derivative of the numerator, numerator, derivative of the denominator over the denominator squared. And that's the different looking one. That's where we're going to need implicit differentiation. An implicit equation is when we have the variables mixed together. Here we have all x's. Here's g as a function of x, h as a function of x, but we can't say that y is a function of x and y. We have them mixed together. Before we do the quotient rule, why don't we reduce it? So we can divide the x into both of those. If you use the quotient rule, you get the same answer, but this is easier. All right, let's look at how do we find the derivative of that. Let's start with an example. And we will review the chain rule. All right, so if we wanted to find the derivative, we would do the derivative of the outside, 2 times 3, 2 minus 1, leaving the inside the same, times the derivative of the inside. That would be 6x squared. And in this problem, we could also just expand it and just do one power rule. But here, for this, to show the chain rule, to show the implicit differentiation, we're going to do it like this. And we could combine all of this. We have 1272x to the fifth. All right, now what if we had the value of y was hidden in a box? We don't know the value of y, but we had f of x equals 3y squared. So this is all we can see, and we can't see what y equals. So what would we do here? We could just say f prime is, we'll do the derivative, and we'll say, well, y could be something. I don't know what y is, but I do see that there's an inside and an outside. So let's just do the power rule, leave the inside the same, and since we don't know what y equals, we'll just write y prime. We could also write dy dx. So we won't have function notation when we're dealing with implicit differentiation, but this was just to show that here's the new concept or the new appearance that you'll see when you do implicit differentiation. If we're differentiating with respect to x and we have some other variable here, then we also have to do times the derivative of that variable, because y is equal to some function of x or equal to some expression with x. So then we have to say we don't know what y is, but we're going to multiply it by its derivative just because we're doing the chain rule. So now let's see how to do the equation there. And all we have to remember from this is that if we ever take the derivative of y, then we'll also multiply by y prime. And now we see that there's a product there. We'll need the product rule. So let's go ahead and do the product rule. That requires this. And that will be the first times the derivative of the second. The derivative of y is y prime. We can also write dy dx. And then we'll have the second times the derivative of the first. We'll do the derivative of y squared. Well, y is some function of x, so we'll have to do the chain rule where we have the outside is the 2, multiply by 2 and subtract 1, leave the inside the same, times the derivative of y, which is dy dx. Since we don't know what y is, we just say, well, there's its derivative, whatever it equals. And then the derivative of y is dy dx. So that's how we can find the derivative of an implicit equation. From here, we would want to isolate dy dx. So let's go ahead and do that. Everything with a dy dx stays on the left. Everything without a dy dx will go to the right. Or it's going to be easier just to move this one over there and leave that there. 2xy, leaving that there. And now we have 2y dy dx so we just subtract this to the other side, and now we'll factor out a dy dx. So each of these terms has dy dx. There's a 1 there, x squared there, 2y. Then we'll just divide both sides by this. And we need to know what this phrase means. The derivative of y with respect to x. If you see that, you're going to say the derivative of y with respect to x. And this notation corresponds to that phrase. So try, and you can write it like this, or you can write it like that. All right, pause the video and try finding the derivative of this implicit equation. And we're going to see that we have sine, and y is an inside function, so we're going to do the chain rule, which is what implicit differentiation is. So the derivative of the outside, leaving the inside the same, times the derivative of the inside. Here we have an inside and outside. We're doing chain rule, but here it's called implicit differentiation, so we're going to multiply by 2, subtract 1. That's the derivative of the outside, leaving the inside the same, times the derivative of y. Now we have x, and we're differentiating with respect to x, so we don't have to worry about a chain rule here. We just do the derivative. The power rule gives you 1, and we need to have dy dx on the same side. So cosine y dy dx. We're going to subtract this, minus 2y dy dx equals 1. Then we factor out the dy dx. And then divide. So dy dx is 1 over cosine y minus 2y. All right. Pause the video and try that one. Everywhere that we see a y, we have to remember to multiply by dy dx. So if we think of this as being the inside and that's the outside, we'll do the chain rule. 3 times 2 is 6. 2 minus 1 is 2. Leaving the inside the same, times the derivative of y. I wrote dy dx, so I should write dy dx here and don't put the prime. Okay, the derivative of x is 1. The derivative of y is dy dx. And the derivative of x squared is 2x. Then we just put dy dx on the same side. We have 6y squared minus dy dx, negative 2x minus 1. Divide by that, and we're all done. Okay, try that one. Pause the video, and we'll have the derivative of this is 2. The derivative of this is dy dx. And here we have to do the derivative of the outside, 2y to the 1, times the derivative of the inside, dy dx. And hopefully you did not forget to use the product rule here. It's a product, so we'll say 1 d2 plus 2 d1. The first times the derivative of the second plus the second times the derivative of the first. And we need all the dy dx's on one side. So here's a dy dx minus 2y dy dx. Let's subtract this. We have a y from there and then minus 2 from there. And factor out the dy dx. There's a 1 minus 2y minus x, y minus 2. And we have dy dx, y minus 2. That looks familiar, like we already did that one. Alright, pause the video and try that one. Product, so we need the product rule. That'll be the first times the derivative of the second, 2y dy dx. And then we'll have y squared times 1. So this says 2y dy dx, that's the derivative of y squared. Then we have to do the derivative of y, so that's dy dx. The derivative of x squared is 2x, and the derivative of 2 is 0. Let's keep everything with the dy dx on the left. 2xy dy dx minus dy dx. And then we'll subtract this. Subtract that. Alright, we can also find the equation of a tangent line with an implicit equation. And that just requires that we find this slope and then do the point slope formula. To find the slope, we're going to find the derivative. So that's going to be dy dx, 2x. And let's look at this as a product like that. So we'll say the first times the derivative of the second plus the second times the derivative of the first, 2 dy dx. The derivative of 2y is 2, but then we also have to multiply by the derivative of y. And let's isolate dy dx. So that's going to be all of this moving to the left. 2x dy dx. And then here we have 2x plus 2y. We need to evaluate the derivative at 2. We also need to find a y value at 2. This requires that we know the y value. We don't know the y value yet. We will need the y value when x equals 2. Let's just look over here. Let's solve for y when x equals 2. Say 4. This will be plus 4y. So we can subtract 4y. So this is not the point slope formula, it's just finding a y value. We have negative 4/3. So let's go back over here, and we're going to evaluate dy dx when, or evaluate dy dx at 2, negative 4/3. X value is 2, y value is negative 4/3. X value is 2. And we could just, let's go ahead and write that as 12/3 minus 8/3 times negative 1/3, because with that, dividing by 3 is like multiplying by 1/3, and we have negative 4/9. That's the slope. So now we go back to the point slope formula. Y minus a y value equals m x minus x. The y value we found there and subtract 4/3, but why don't we just write this as 12/9. So this is 12/9. We'll subtract 12/9. And we have the equation of the tangent line. Okay, and let's find the second derivative implicitly. So that's how we write the second derivative. And we're going to start by finding the first derivative. So we have dy dx. The derivative of x is 1. Here the derivative is 2y dy dx. And then the derivative of 1 is 0. Let's isolate. We're just repeating everything that we've done already today. Factor out dy dx. And divide. So then we have to find the derivative of this. This is the first derivative. And now we need the second derivative. The second derivative is the derivative of this. And here's a quotient, so we need the quotient rule. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. So that is, the derivative of this is 2 dy dx. And that will be 0. Oh, the denominator squared. And we're not going to leave it as dy dx because we already know what this equals. We're going to substitute and then we'll be done. So that's all 0. We'll have a positive 1, and then it's just going to be 2 times this. And we could rewrite this as negative 2 over 1 plus 2y cubed, because we could multiply the numerator by the reciprocal of the denominator. We'll get that. Alright, pause the video and try that one. There's no y here, so we'll just do a normal derivative. The derivative of cosine is negative sine. And here we have a y, so we're going to be multiplying by y prime. The derivative of sine is cosine, leaving the inside the same, times the derivative of y. There's the chain rule. We'll do another chain rule here, 2y dy dx. And the derivative of 5 is 0. Let's move that to the other side and factor out the dy dx. Divide by this factor, and now we have the first derivative. Then we'll find the second derivative with the quotient rule. So we have the denominator times the derivative of the numerator times the derivative of the denominator. So the derivative of this is negative sine y dy dx minus 2 dy dx. So this says 2 dy dx right there. And I think for now we'll just stop here. No, we'll not stop here. We need to replace the dy dx. So let's factor out the dy dx here. These both have a dy dx. So let's just put it out in front. Okay, so the sign just stays there. That's a factor. But here we have dy dx, and then the 2 and sine y. So they just stay there. We take the dy dx out in front, and that's what this space is for, dy dx. And in that space will go this, dy dx. So just write that in there. And we'll just stop there. We want to try to simplify that. Okay, and that's the end of this lesson.